recall the integration by parts formula. Integral of u dv dx is equal to uv minus integral of v du dx. So let u to be equal to cos 2x and dv dx to be equal to e to the x. You can do the other way around, but in this video we are going to do this one, and in another video we'll see how we can do the other way around. So let's begin. We let u equal cos 2x, then we find du dx, which is negative 2 sine 2x. Then we let dv dx to be equal to e to the x. And then integral of both sides will give us v to be equal to e to the x. Let's ignore the constant of integration for now. Now, when we do the substitution back into this formula, we will obtain integral of u, which is cos 2x, then dv dx, which is e to the x. The dx is already there. Then we have cos 2x, which is u again, then v, which is e to the x, minus integral of v, which is e to the x, then du dx, which is negative 2 sine 2x dx. Now what do we do next? Let's rewrite this one neatly to obtain something like this. Cos 2x e to the x dx will give us e to the x, e exponent x cos 2x plus 2. So the integral of a constant is the constant of the integral. So this negative 2 multiplies the whole thing to give us positive 2 times e exponent x sine 2x dx. So again, what we are seeing here is similar to what we are seeing here. So the process we use to integrate these, we are going to use the same process to do this. So our integral becomes like this. Integral of cos 2x e to the x dx is equal to e exponent x cos 2x, which is already here, and plus 2. So we will let u again to be equal to sine 2x, then v equal e to the x, then we substitute it into the integration by parts formula. So when we do that, what are we going to get? You'll get integral of cos 2x e exponent x dx is equal to e exponent x cos 2x is already there, plus 2. Then now our u, which is sine 2x, times e exponent x, which is there, v. The integral of v dv again will give us this. But this time when we integrate, when we differentiate sine 2x, we get 2 cos 2x. So that is what we get here. When we let u equal sine 2x and we differentiate, we find du dx, we will get 2 cos 2x. So what we have to do now is to rewrite this nicely. The constant will come out to multiply, so that will give us this expression for our integral. So we have minus 2 multiplying the whole integral here. Then what do we do next? We use the 2 here to expand, to multiply the sine 2x e to the x to give us what we are seeing here. Then we use it again to multiply this to give us what we are seeing here. So what do we do next? We now realize that this part of the integration is the same as what we started with. So we group them. We group the two of them. We group the like terms. So when we group like terms, we have what you're seeing on the left hand side of the equation, and this is left on the right hand side of the equation, which is what you're seeing here. Now what do we do next? We now combine, just like one of these plus 4 of the same thing will give us 5 of that 5 of e exponent x cos 2x dx is equal to what you're seeing here. So we now have to divide through by 5, then factor the e exponent x to get what you're seeing here, which is exactly what we started with. So we've now shown that the integral of e exponent x cos 2x dx is equal to what you're seeing here. Thank you for joining us. In our next video, if you want us to do so, you do the other way around, where we will let u equal e exponent x and divide the x to be equal to cos 2x. If you really want us to do that, just then share this video and let me see it in the comments. Thank you for joining us. See you in the next video.